Start count. It's easy to talk about MRI. MRI, magnetic resonance imaging, okay? Easy to talk about MRI, only the patient is placed on the magnetic field, okay? And we send energy using coil, and the patient absorbs this energy, and after we switch off the source of energy, the patient relaxes again and resend, or the signal which the patient is absorbed sent back and to receive it and to be converted to image. Yes, this is an easy idea about MRI. That the radio wave, the patient, when the patient is placed inside our magnet, what happened for the patient? Okay, the patient, you will find that 70%, around 70% of patient content is water. Our bodies is composed of water, okay? Water is hydrogen molecule. Hydrogen molecule, okay? So, this hydrogen molecule is like positive charge. This proton, hydrogen, okay? You will find inside the nucleus proton. This proton has positive charge, okay? And this proton is positive charge. Always you will find this proton in a spinning motion, like that. Always you will find the proton in spinning motion around its axis. So now, hydrogen atoms, or hydrogen is proton, okay? This proton has a positive charge. Positive charge is current. This current moving around its axis, so it has magnetic field. Any electrical current is accompanied by magnetic field, which is called electromagnetic field. Electromagnetic field, you will find any electrical current passing through our wires, you will find magnetic field. The electrical power here in our laptops or computers produce magnetic field. This magnetic field is normal state. Okay, you will find magnetic field with electrical current. So, with this positive charge moving around its axis, the proton inside our bodies, okay, produce magnetic field. You will find inside our bodies, the patient body, the proton are aligned in random directions. In random directions, the protons now are aligned in random directions. You will find proton pointing up, and another one pointing down, and another one for left, and another one for right. So you will find the protons in random, distributed randomly inside our bodies. Yes, that's before placing the patient inside the magnet. That's before placing the patient inside the magnet. So now, the protons inside our bodies are randomly distributed. Now you understand? It's clear? Protons are inside our bodies are randomly distributed, okay? So now, you have a magnetic field inside your body, yes? And me. All of us has a magnetic field, yes or no?
Yes.
Yes. This magnetic field may attract each other. Because now we are attracted to the earth. Okay, like gravity. Okay? If you find magnet, this magnet can attract any metals. Why? Because this magnet has a magnetic property. Now you become magnet, and me, all of us. And why? Why we are not attracted to each other? Because now you have protons inside your body. These protons has a positive charge These protons have a positive charge. This positive charge produce magnetic field. So you have magnetic field inside your body. And me, why we are not attracted? This is a question. Because your net magnetization is zero. Zero. That means that any two opposite force neglect each other. You'll find the protons pointing up, and another one pointing down, and another one pointing right, and another one pointing left. Two opposite force, the same force, two equal and opposite force neglect each other. So the net magnetization force is zero. That's before placing you in the magnetic field, in the MRI room. Okay? It's clear? After that, I will put you inside the MRI machine. The proton is in motion like Earth. Like Earth, you'll find the Earth is moving around its axis, like protons. So proton, small magnet, okay, producing magnetic field. Okay, so now the protons in random motion, that's outside the magnetic field. All of us went to see the magnetic machines or MRI machine, yes? Like 2Ds, yes? One up and another one down, yes? This is the two poles of magnetic field, south and north. Okay? So, in between, if you put any metals, it will be attractive. Yes or no?
Yes.
Yes. Why? Because there is magnetic field lines from south to north. These lines of magnetic field, this is the direction of this magnetic field. Okay? When we put the patient inside the magnetic field, what will happen for him? His protons. His protons align in the direction of magnetic field. His protons align, all of them be straight. Not randomly distributed, but now it's straight. Because the external magnetic field affecting on the protons to be in the same line with the magnetic fields. But the protons may be parallel to magnetic field or anti-parallel to magnetic field. So now, when we put the patient inside the MRI room or inside the MRI machine, what happened for protons? Protons now aligned straight. And these protons become two types. It's converted to types. One of them will be parallel to the magnetic field, and another one will be anti-parallel to the magnetic field. But all of them straight. All of them straight. Okay? So, now, here, parallel to magnetic field, these protons are anti-parallel to magnetic field. Like what? Like people moving on their feet, they are relaxed. Now protons which are moving parallel to the magnetic field are relaxed. Okay? No need more energy. But other protons moving on their hands, they need more energy. So the protons which are anti-parallel, it will be in an excited state because need more energy to be on their hand. But the protons which are moving on their feet, they are relaxed. So it will be in a relaxed state. Okay? You understand? Okay, so after we put the patient in the sorry?
The protons are already aligned between the north and the south.
South to north.
Yes. So they align from south to north.
Yes.
And does that depend on the source of the magnet, source of the stomach?
Sorry?
The source. Does that also depend on the source?
external magnetic field. Now we have a machine, MRI machine, 0.5 Tesla. If we increase the magnetic field, the alignments, the effect of magnetic field will be on a large number of protons. Okay, increasing the magnetic field, increasing the effect on large number of protons. Okay, or do you have another question?
Actually, continue.
No, you have a question?
No, I don't have a question.
It's clear? Okay, so now, protons aligned with the magnetic fields. But the direction of, you'll find here, the protons aligned with the magnetic field like that. Some protons will be down. Okay? It's parallel to the magnetic field, but the direction is different. Okay? Okay? So, and the protons moving in precision motion. I told you before that protons have spin motions, okay? And protons, after external magnetic field, will acquire another motion. It's called precession. So at the same time, spin around its axis and moving like wobble. Okay? Like wobble, okay? It's moving in precession frequency, precession motion. This precession speed depends on the external magnetic field. This precession frequency, how many cycles per second, depends on the external magnetic field. Now we have to calculate the frequency of precession, which is omega, is the gyromagnetic ratio is specific, is the constant, is specific for protons and carbon, different material. For each one has a specific gyromagnetic ratio times B naught. What is B naught? B naught is the external magnetic field. Okay, so increasing B naught, that means the precession will be increased. Yes. So precession. So when we put the patient inside the MRI machine, what happened? The protons aligned with the magnetic field and
Speed.
Yes.
And precision.
Start to precess. And the speed of precession depends on the external magnetic field. Okay? So now we have protons parallel and we have another proton anti-parallel. The question, one proton pointing up and another proton pointing down, neglect each other. Two opposite forces and two equal forces will neglect each other. Yes, you are right. That will happen. But you will find that if 1 million protons pointing up, 1,000,007 protons pointing up, you will find only 1 million proton pointing down. So, what is the difference? 7. These 7 protons enable us to get image. So, we excite all protons inside your bodies, okay, using MRI machine. But all the protons which are pointing up will be neglected with the protons which are pointing down. So the net result is the difference between the number of protons, which is 7. Not only 7, maybe more. Okay? But in 7 in million. 7 in million proton. Okay? 7 in million protons. Okay? So now, million pointing up, million proton pointing down, neglect each other. So I have 7 protons. These 7 protons enable me to get image. Easy. Now we will excite these 7 protons. Now we will give it energy, radio waves, and 7 protons will acquire this energy and will be transformed from relaxed state to an excited state. After a certain time, I will switch off the source of energy, and the protons will be relaxed again. After relaxation, will emit radio waves. I will acquire these radio waves again and convert it to image. Yes? Now the idea become simple, yes? Yes? So, this equation for omega, precession frequency, you will find here P naught is the strength of the external magnetic field. Now, the unit of magnetic field is Tesla. This machine 0.4 Tesla, another one is 1.5. Increasing the magnetic field strength, just increasing the precession frequency. Because now you will affect on a large number of protons, okay? So you will get the image very fast. So, here, these protons, these arrows, are representing the protons. These arrows are representing the protons. Now, I have protons aligned up and I have protons pointing down, as we see. Yes? Yes? Okay, so each proton in certain direction will be, the magnetic force will be neglected with another proton in another opposite direction. In the other opposite direction. So the net result will be these protons. These protons, okay, which is 4 protons pointing up, the net magnetization of these protons, okay, from 1, 2, 3, 4, will be in the Z direction. Z direction is the direction of the magnetic field. Z direction, I have 3 directions. Z is the direction of the magnetic field, okay, and X and Y direction. Okay, so now the net magnetization, it's called longitudinal magnetization. It's called longitudinal magnetization. Okay, this longitudinal magnetization, the net magnetization of all protons pointing up. Okay, now all protons pointing up. Each one of these arrows, okay, represent protons. Okay, all of them pointing up. So the net magnetization, all of them, all magnetization coming from each proton will be added, will be summed to form net magnetization. It's called longitudinal magnetization. It's called longitudinal magnetization. So Z, X, Y. Okay. So now I will give these protons radio waves. These radio waves has frequency. Why MRI is called magnetic resonance imaging? Resonance. Why? Because the frequency of the incident radio waves has to be the same with the precession frequency of protons. Like, if we are in race and 2 cars is moving very fast with the same speed, so the energy can be transferred from this car to another. Now, 2 cars moving very fast, but the 2 cars, this is the protons in the magnetic field, and this one, this sandwich is the radio waves, which I want to transfer it, okay, from the coil to the patient. If we are moving in the same speed, if the frequency of protons inside the patient is the same as the frequency of the radio waves which is coming from the coil, so the energy transfer will done. The energy transfer will be done so easy. But if we are moving like that, you will send the radio waves with different frequency. You will send the radio waves with different frequency than the frequency of protons inside the patient. So the energy cannot be transferred. This is called resonance. You are hungry now? It's clear? So it's important to know the frequency of protons, the precession frequency of protons, because at first we have to know the precession frequency. The precession P. I want you to consider this point, please. Okay. Now, we placed the patient inside the MRI machine. What happened? Before putting the patient inside the MRI machine, what was inside his body? The protons are randomly distributed. Yes.
So when you put them in,
yes. When we put the sorry, that's enough for you. Okay. When we put the patient inside the MRI machine, what happened? Huh? Who knows?
First you had the protons in a random fashion, but in the MRI machine,
yes,
from the magnetic source, they are now in an ordered fashion.
Yes, the protons will be aligned. Yes, will be aligned, straight aligned with the lines of magnetic field, and will acquire precession frequency. This precession frequency depends on
State of the magnetic source.
external magnetic field. When we are using higher magnetic field, the precession increase. So it's easy to calculate the precession frequency or not. Easy. Yes, because we know gamma gyromagnetic ratio is a constant for hydrogen, and the magnetic field we have to know it, 0.5 or 0.4. So now it's easy to calculate the precession frequency. So now we know the precession frequency of protons inside the patient. So we can send radio waves with the same frequency. So the energy transfer will be happening. So the resonance, yes.
Probably I missed that part. I was just wondering why the protons are lined up in two different fashions once they get magnetized, one up and one down.
Sorry, the question. I can't understand.
You know, when you were drawing, you said there's two different directions by which the
Yes, proton pointing up and another proton pointing down. Neglect each other.
right. So why not they point in the same direction?
Why not? Because the protons which are aligned in the direction of the magnetic field, okay, this proton is in relaxation state. Okay? But the protons which are aligned in the opposite direction in excited state. So, not all protons will be affected with the magnetic field, okay, with the same value. You will find difference. This difference, but it's easy to understand that it's preferable for protons to be in the relaxation state. So the number of protons in the relaxation state is greater than the number of protons in the excited state. Okay? All of them will be affected to be in the same direction. Okay? To be parallel. But some of them will be parallel and another will be anti-parallel. Okay? So now we will. So now, talking about sandwich transfer, okay? To transfer sandwich or to transfer radio waves, okay? So we need resonance. We need to transfer, to transmit, to send radio waves with the same energy, with the same frequency of our precision frequency of protons inside our bodies. You understand? So now this is a radio frequency pulse coming from the coil. The protons acquire this radio frequency pulse. So what happened for longitudinal magnetization? You remember? The protons acquire this energy and the protons in the state of longitudinal magnetization will be like that, dephased. But after acquiring the energy, will be converted from the relaxation state to excited state, from the Z direction to Y direction. So the net magnetization here will be transversal magnetization, will be transversal magnetization, and the protons here, okay, will be converted from relaxation state to an excited state. So, what happened for longitudinal magnetization? Decreased or increased? Decreased, because the number of protons here, which are pointing up, number of protons will be reduced. Okay, because some protons will acquire energy and be in the opposite direction. So the longitudinal magnetization decreased, and another magnetization appeared, which is transversal magnetization. Now, when I send the radio waves, these radio waves causing all protons to be in phase, to be in synchronization, like that. When I send these radio waves, all of them moving in synchronized, not the phase, but in phase. Okay, so the protons will be in phase, not out of phase, not like that. Here, the protons dephased, or each one, there is a big difference, distance between all of them, okay? But here, all of them summed together, okay? That means phase, in phase, okay? And this causes another magnetization appear, which is called transversal magnetization. Okay, so now use me for 5 minutes and I will finish. Okay, now Z, X, Z, Y, X. Okay, the protons in the relaxation state. Okay, this magnetization is called longitudinal magnetization. Okay, so well, send RF pulse, radio frequency pulse, or radio waves. What happened for protons? Now the net magnetization in Z direction, but the protons will be phased and will be in XY plane, like that. This is the direction of transversal magnetization, okay? And longitudinal magnetization is reduced, okay? And another transversal magnetization appeared, okay? So when we switch off the radio waves, what happened for these protons?
They go back to the
yes, go back to the relaxation state, okay? So it will be like that, yes? And will emit the radio waves. These radio waves, I will acquire it using receiver coil, using the coil, okay? This coil can receive these radio waves, okay, to convert it to image, okay? But there are differences inside our bodies between different tissues. You will find fat, fast excited and fast for relaxation. You will find the fat, it's fast to excite it, quick to be excited, and quick to be relaxed. But water, no. Water, slow in excitation and slow in relaxation. Takes time to be relaxed and takes time to be excited. So, if we assume that we have two protons, one of them is fat and another one is water, okay? Because fat has hydrogen atoms and water has hydrogen atoms, okay? So, after a certain time, after we send radio frequency pulse, you will find that water takes time to be excited, but fat fastly excited. Now, all of them will be in this direction, okay? Okay, you will find fat fast excited, but water takes time. Okay, after long time, all of them will be excited, okay? And after you switch off the radio waves, what happened? Fat coming back, go back fastly to its relaxed state, but water takes time. So at certain time, if we record the signal coming from fat and water, you will get different signal. Yes or no?
Like the T1, T2 weighted image.
Yes. Because it's according to the tissue properties. Okay? Fast excitation or slow excitation, you will get signal, different signal. You will get different signal because fat, fast excitation and fast relaxation. After certain time, if you record the signal coming from fat, already fat is relaxed, so no signal coming from it. Okay? Okay? So now you will record the signal only from water. Okay? And next session we will talk about the difference between T1 weighted image and T2 weighted image in more details. But now the basic idea for MRI is clear. Yes? Do you have any question? It's clear for all? Thank you. Thank you so much.